Good morning everyone. My name is B. Ravi Babu. Now today we are going to discuss about operation of NPN transistor. Okay. So now let's talk about operation of NPN transistor in the sense that is emitter, base and then collector. Okay. Now which is connecting as a supply voltage, that is active mode, and we have three types of transistor regions. There are three regions are one is active region, saturation region and cutoff region. In three regions, which one is used in the transistor? In the sense, we may go for the active region. It consists of two biasing. One is forward bias and other one is reverse bias. Okay. Now in this emitter, base junction is forward bias and collector base junction is reverse bias. Okay. So based on this supply voltage, it will be operated. How the current will be flow in this operation of NPN transistor? Let's see now. Okay. Now NPN, which is called as NPN transistor. In emitter region, the number of electrons are majority in the N region and holes are the minority in the P region, and the electrons are the moderately in the N region, which means why it is in this N region maximum of number of electrons are majority and holes are the minority and moderately electrons are in the N region, because emitter is heavily doped, so that maximum number of electrons present in the emitter, whereas holes, it is a thin layer and then small size, so it is lightly doped, so that in P region holes are the minority charge carriers, whereas in collector region, collector is a moderately doped. Okay, so that compared to the emitter, somewhat lower, that is what electrons are the moderately doped in the sense of collector region. I can say that 100% of electrons present in the emitter, 5% of holes in the P type, base, and then 75% of electrons present in the collector region. Okay, so heavily, lightly and then moderately. Okay, let's see now. I need to connect a supply voltage to the emitter and base. What type of supply? That is forward bias. Forward bias. Now as we know that operation of forward bias, that is P and N, we were talking about emitter base junction, so that we need to connect supply voltage between emitter and base junction. Okay, now it is acts as a forward bias. So here in emitter region, N is the type. So here which charge carriers are present? Electrons are the present. So these electrons, and here negative is connected, which means N is going to connect to the negative terminal and the P type is going to connect to the positive terminal. Okay. Now this is nothing but forward bias. Whereas comes to the reverse bias, that is collector and base junction. Okay, here in base junction P type and collector junction N type. So it is reverse bias condition. So the polarity should be reverse, because here forward bias condition, that should be negative to negative, positive to positive, because it acts as a forward bias condition. Then only you can say that forward bias. But here it acts as a reverse bias, so that across the junction between P type and N type, across the junction, P type is going to connect to the negative terminal and N type is going to connect to the positive terminal. So it should be acts as a reverse bias condition. Now I have given us supply voltage to the respect to forward bias and reverse bias. Now I am going to increase the supply voltage between emitter base junction voltage, VBE. When I increase this voltage, from the emitter region, the electrons starts moving from emitter to base region. Okay, how much electrons are here? I can say that maximum number of electrons, that is 100% of electrons are present in the charge carriers in the emitter region, because it is heavily doped, so that maximum number of electrons present in the emitter, so that I can say that 100% of electrons. Now these electrons move towards the emitter region to base region. Then here, whenever reaches cross over to the here, then 5% of holes present in the p region. So among 100% of electrons, that 5% of electrons recombination takes place with holes. Okay, 5% of electrons coming from emitter, that electrons collide with holes. That's it constitutes base current. Okay, so 5% of electrons collide with holes, then it constitutes base current. That is what IB. Okay, whenever crossing from emitter to base, it constitutes collector current, emitter current IE. Whereas wherever these electrons and holes recombination takes place, then it constitutes IB. Then how much electrons are remaining left in this? 95% of electrons remaining. That electrons passing from base to emitter. Okay, so from base to emitter, then this 95% of electrons moving from base to emitter, and then total electrons collide with collector region, collector terminal. That is, here already how much of electrons present? 75% of electrons present in the collector region. Now again coming from base to collector, 95 plus 75, around 170% of electrons present in the collector region. That is, that much of high current present in the collector region. The total current goes to the again emitter. Okay, now we should calculate the basic emitter current. IE equal to IB plus IC. So here IE equal to IB plus IC is the basic current, but in which terminal current is maximum? You can say that here current is maximum and here current is maximum, but in the case of base region, there is a 5% of current only presence in the base region compared to the emitter and collector. So that we can say that this should be written as IC is approximately equal to IE. Is it clear? So because I should be neglected about base current, because there is a little current only presence in the base region. So that finally you can write as IC is approximately equal to IC. What are the current passing here emitter? The total current collected by the collector region and again goes to the emitter. So that's why you can state that standard equation IC is approximately equal to IE. Okay, so this is about operation of NPN transistor. Okay, so is there any doubts regarding this concept? Please drop a message in my comment box. Okay, thank you for watching my video.